The stones froze. The mortar did not set, but they continued to build. How were medieval castles built in winter? Medieval craftsmen did not give in to the elements, but developed a whole arsenal of unique technologies and methods that allowed them to continue construction even in the harshest months. They learned to cheat the cold by changing the properties of materials and organizing the work process so that every winter day was used with maximum efficiency. Watch the video to the end to learn how medieval engineers use fire, straw, and manure to bend stone to their will in the middle of snow-covered plains. Contrary to popular belief, winter castle construction did not begin with the first snowfall, but long before that, at the planning stage. The experienced master builder who oversaw the construction of the fortress viewed the cold season not as a pause, but as a special stage of work that required careful preparation. The success of the entire project depended on how accurately he could foresee future difficulties and prepare for them in advance. Medieval architects had a deep knowledge of the climatic characteristics of their regions, passed down from generation to generation.
This section requires more reinforcement.
They carefully studied the experience of previous construction projects, analyzing the mistakes and successes of their predecessors. This approach allowed them to create detailed plans that took into account all possible natural obstacles and seasonal limitations. Planning for winter work began in early spring, when the total volume of construction for the entire year was determined. The master builder drew up detailed work schedules, with each month having its own specific tasks and priorities.
Pay close attention to the details of the foundation here.
Particular attention was paid to calculating the number of workers needed to complete the various stages of construction during the winter. The main task during the summer and autumn months was to collect and accumulate resources on an industrial scale. Thousands of stone blocks were quarried and then transported to the construction site and stored under temporary sheds to protect them from moisture. At the same time, timber was harvested for scaffolding, beams, and interior finishing, as well as a huge amount of firewood, which became a key strategic resource in winter. Each stone block was pre-processed and marked during the warm season, when stonecutters could work in comfortable conditions. Special craftsmen created precise templates and patterns for future architectural elements, which were then used in winter for the final fitting of parts. This approach significantly accelerated winter work and made it possible to avoid complex operations in adverse weather conditions. The procurement of wood required special attention to the quality and species of trees used for various purposes. Oak was intended for load-bearing structures and durable elements, while pine was used for temporary scaffolding and auxiliary structures. Birch and other fast-burning species were harvested exclusively for heating workrooms and workshops. At the same time, stocks of lime for mortar, sand, and clay were created, which were also protected from the weather. The craftsmen understood that in winter, the delivery of materials along snow-covered and muddy roads would be practically impossible, so everything necessary had to be at hand. Such foresight made it possible not to stop work completely, but only to change its nature depending on the weather. Lime required special storage conditions, as it lost its binding properties when in contact with moisture. For this purpose, special covered warehouses with raised floors and good ventilation were built. Sand and clay were stored in huge pits covered with wooden shields and straw to prevent freezing. The organization of warehousing was a whole science, requiring precise calculations and logistical planning. Materials were arranged in order of use, taking into account the convenience of transportation to the work sites. Special storekeepers kept detailed records of all stocks and monitored their condition throughout the winter period. In addition to material resources, great attention was paid to preparing human resources for winter construction. Masters selected the most experienced and hardy workers to continue working during the cold season. Warm barracks and workshops were organized for them, where they could work and rest in relative comfort. We would be very interested to hear your opinion. What do you think about this level of planning in the Middle Ages? Please write your thoughts in the comments.
Yes, master.
It is not setting.
The main technical problem with winter construction was lime mortar, which was the main binding element in masonry. The chemical process of its hardening, or carbonation, requires the evaporation of water and the absorption of carbon dioxide from the air. At sub-zero temperatures, the water in the mortar froze, turning into ice crystals that broke its structure from within and prevented it from gaining the necessary strength. To overcome this obstacle, medieval builders developed several ingenious solutions based on the use of heat. First, they began to heat the key components of the mortar, sand and water, before mixing. Large fires were constantly maintained on the construction site, or special braziers were used to heat these materials in metal cauldrons and on baking trays. The heated mortar had to be used immediately before it cooled down, which required perfect coordination between the workers mixing it and the masons on the walls. This method was labor-intensive and expensive, as it required a huge amount of fuel, but it allowed masonry work to continue even in light frosts.
The mortar is holding well.
How durable do you think masonry made using such hot technologies was? In the next chapter, we will reveal even more unusual methods that medieval craftsmen used to make mortar work in the cold. When simply heating the components was not enough, more complex and unique technologies bordering on alchemy were used. One of the most effective was the hot mixing method, which used quicklime, calcium oxide, instead of slaked lime. It was mixed with wet sand just before use, triggering a violent exothermic reaction. During the slaking process, the lime released a huge amount of heat, literally causing the mortar to boil and keeping its temperature high enough to start the hardening process. Such a hot solution had better plasticity and adhered more strongly to cold stones, ensuring the reliability of the masonry. Working with quicklime was extremely dangerous and required special skills and caution from the workers. In addition, there is evidence that various organic components were added to improve the properties of winter mortar. These additives, such as animal fat or beerwort, acted as primitive plasticizers and antifreeze agents. They slowed down the freezing process of water and made the mortar more elastic, allowing it to withstand cycles of freezing and thawing without fatal structural damage. Another serious problem faced by builders was the freezing of the ground and the building materials themselves. Working with frozen ground was practically impossible. Digging a trench for a foundation or basement in such conditions became a Herculean task. Therefore, all earthworks were attempted to be completed before the onset of sustained cold weather. If it was necessary to work with the ground in winter, it had to be warmed up. Large bonfires were lit above the future worksite, which burned for several days, gradually melting the top layer of soil. This method was extremely inefficient and expensive, so it was only used in the most extreme cases when construction delays were unacceptable. Stone blocks left in the open air also suffered from frost. Moisture that got into microcracks froze, expanded, and could crack even the strongest stone. To protect the prepared materials, they were covered with a thick layer of straw, dry leaves, or even manure. These organic materials created a heat-insulating layer that protected the stone from sudden temperature changes and destruction. How did medieval workers protect not only the materials, but also themselves from the cold? In the next chapter, you will learn about their daily life on a winter construction site. The survival and working capacity of thousands of people employed in construction were key factors in the success of the entire project. Temporary settlements were built near the construction site to house the workers. Rows of simple wooden barracks or huts. In winter, these dwellings were additionally insulated with moss, straw, and earth. And in the center of each building, there was a hearth for heating and cooking. The temporary settlements were built to provide maximum protection from wind and snow, often located in natural shelters or behind specially erected fences. The barracks were designed to accommodate 8 to 12 people each, which provided sufficient heat from human bodies and saved firewood. Plank walkways were laid between the rows of dwellings so that workers would not sink into the snow when moving around the settlement. Each barrack had double walls with a layer of dry leaves or straw in between, which provided additional insulation. The roofs were reinforced with a thick layer of turf and snow, which paradoxically served as an excellent insulator. Special reflectors made of stone or clay were installed around the hearths to direct heat into the living area of the barrack. Organizing life in such settlements required strict discipline and a clear distribution of responsibilities among the inhabitants. Those on duty were responsible for maintaining the fire in the hearth, gathering firewood and water, and keeping the room clean. Particular attention was paid to ventilation, as smoke and moisture from people's breath accumulated in the enclosed space. The working day in winter was significantly shorter due to the lack of natural light, and outdoor work ceased at dusk. Workers' meals during the cold season were more caloric. Their diet included more meat, fats, and hot soups, which helped the body generate the heat necessary for warmth. Construction managers understood that skimping on food and firewood for workers would lead to illness and decreased productivity. The winter working day began at dawn, which came very late in December, and ended with the first signs of darkness. On the shortest days of the year, effective working time was only 6 to 7 hours, compared to 12 to 14 hours in summer. To compensate for the short daylight hours, the foreman organized work indoors by the light of torches and oil lamps. The calorie content of a worker's winter diet reached 5,000 calories per day, which was almost twice the summer norm. The diet consisted mainly of fatty meat, lard, thick porridge made with animal fat, legumes, and coarse ground bread. Hot meals were served at least 3 times a day, and each meal included hot drinks, herbal decoctions, mead, or hot beer. Organizing meals required a large staff of cooks and special kitchens capable of feeding hundreds of people at once. Ice houses and smoke houses were built to store food, as well as special warehouses for grain and other dry goods. Meat was preserved by salting, smoking, and freezing, which ensured a steady supply of protein throughout the winter. Workers' clothing consisted of several layers and was made of coarse wool and leather, which retained heat well. Thick mittens were used to protect the hands, and leather shoes, insulated with straw or pieces of fabric, were worn on the feet. Despite all these measures, working in the icy wind remained an extremely difficult task, requiring exceptional endurance from the workers. The multi-layered clothing system included linen underwear, a woolen shirt, a vest or caftan, and an outer cloak made of thick wool or leather. Particular attention was paid to protecting the head. Woolen hats with ear flaps or leather helmets with fur lining were used. A woolen scarf or shawl was always tied around the neck to prevent cold air from getting under the clothes. Footwear for winter work was made of thick ox leather and had high tops to protect against snow. Felt insoles, dry straw, or even moss were placed inside the boots and changed daily to prevent frostbite. For work on particularly slippery surfaces, metal spikes or rope wraps were attached to the soles. Mittens were sewn from several layers of leather with a fur lining, but finer gloves were required for delicate work. Master masons often worked with their bare hands, periodically warming them by the brazier, which led to constant frostbite and cracks in the skin. For such cases, special ointments based on animal fats with the addition of medicinal herbs were used. Completely stopping construction of the castle in winter was economically unprofitable, so the craftsmen learned to shift their focus from exterior work to interior work. While the construction of stone walls was halted during severe frosts, work continued inside the future buildings and in specially constructed workshops. This allowed most craftsmen to remain employed and not lose precious time.
Our teams to meet these new challenges.
The reorientation of the construction process towards interior work required a radical review of the entire organization of labor and the redistribution of human resources. The master builder had to plan ahead for the winter period so that all the necessary materials for interior work were prepared and delivered before the onset of cold weather. This strategy not only preserved jobs, but also significantly accelerated the overall pace of construction by allowing different types of work to be carried out in parallel. The economic feasibility of continuing work during the winter period lay not only in retaining skilled labor, but also in optimizing the use of expensive equipment and workshops. Maintaining empty workshops and warehouses was almost as expensive as actively operating them, so it was more rational to keep production facilities busy with useful work. In addition, laying off craftsmen for the winter threatened to lose them, as they could find work with other customers in the spring. The system of internal work allowed for the continuity of technological processes and maintained the production rhythm accumulated during the season. Experienced craftsmen knew the specifics of working with each other, which significantly increased the overall efficiency and quality of the work performed. The destruction of such work collectives due to winter downtime could seriously affect the quality of construction in the following season. Winter was the ideal time for carpenters and joiners who were engaged in the harvesting and processing of wood. In large covered workshops, they made roof truss systems, floor beams, window frames, doors, and interior finishing elements. The finished wooden structures were stored until spring so that they could be quickly installed on the already erected walls when the warm weather arrived. The carpentry workshops were real production complexes with different specialized areas for different types of wood processing. In one part of the workshop, there were sawmills for cutting logs into boards and beams. In another, lathes for making turn parts, and in the third, assembly tables for making complex structures. Each section had its own heating and lighting, which allowed workers to work in comfortable conditions, even in the harshest frosts. Harvesting wood in winter had its own special advantages, as trees contain the least amount of sap at this time of year, making the wood less prone to rotting and cracking. Experienced craftsmen preferred to harvest wood in the winter months, when it was possible to select the highest quality specimens and ensure they were properly dried over several months. Such wood lasted much longer and had better mechanical properties. The manufacture of complex wooden structures, such as rafter systems, required the highest precision and skill, as all elements had to fit together perfectly during subsequent assembly. Carpenters used special templates and patterns that allowed them to produce many identical parts with minimal deviations. The finished elements were marked with special signs indicating their place in the overall structure, which greatly simplified the assembly work in the spring. Blacksmiths were also fully occupied with work during the winter, as the construction required a huge number of metal products. In their forges, they forged thousands of nails, door hinges, window grills, locks, and staples. In addition, they were constantly repairing and sharpening the tools of bricklayers and carpenters, keeping them in working order. The smithy worked at full capacity during the winter, as the demand for metal products for the construction of the castle amounted to tens of thousands of items of various types. Each nail, bracket, or hinge was made by hand in accordance with strict quality standards, which required high qualifications and considerable time. Blacksmiths worked in several shifts, keeping the fires in the forges burning around the clock to save fuel and increase productivity. The manufacture of complex mechanisms, such as locks and bolts for gates, was a true art form, requiring not only blacksmithing skills, but also knowledge of mechanics and engineering. The craftsmen created unique locking systems that could withstand break-in attempts and provide reliable protection for the fortress. Each lock was a work of art, decorated with ornaments and the customer's heraldic symbols. Repairing and maintaining tools was a big part of blacksmiths' winter work, since heavy use led to quick wear on cutting edges and working surfaces. Proper sharpening and hardening of tools required a deep knowledge of metallurgy and many years of experience working with different grades of steel. The productivity and safety of all other craftsmen on the construction site directly depended on the quality of the tools. In addition to carpenters and blacksmiths, stonemasons and sculptors were also actively working in the winter, creating decorative elements for the future castle in warm workshops. They made column capitals, coat of arms shields, sculptural decorations, and architectural details that required special precision and artistic skill. This work was carried out according to pre-approved sketches and required months of painstaking labor to create each element. What other technologies allowed builders to move forward when stone masonry was impossible? In the next chapter, we will look at examples of castles built in spite of harsh climates. A striking example of winter construction in extreme conditions is King Edward I's campaign to build castles in Wales at the end of the 13th century. The fortresses of Harlech, Conwy, and Carnarvon were built in incredible haste, dictated by military necessity. Work continued throughout the year, involving tens of thousands of workers from all over England, and stopping for the winter was simply unthinkable. Edward I's military campaign in Wales was a turning point in the history of medieval construction, demonstrating the capabilities of an organized state in overcoming natural obstacles. The king understood that control over the conquered territories was impossible without powerful fortifications, capable of withstanding the constant rebellions of the Welsh princes. Every month of delay in construction meant the risk of losing hard-won lands and the need for a repeat military campaign. The king's strategic plan called for the simultaneous construction of several fortresses, forming a continuous chain of fortifications along the Welsh coast. This ambitious task required the mobilization of all the kingdom's resources and the creation of an unprecedented construction organization. Coordinating work on various sites in harsh winter conditions became a logistical challenge that required revolutionary solutions in large-scale project management. To ensure the continuity of the construction process, a special administrative structure was created, including royal inspectors, logisticians, and treasurers. This system made it possible to quickly resolve emerging problems and transfer resources between different construction sites depending on current needs. The king personally supervised the progress of the work and regularly received detailed reports on the status of each project. Financial reports from that time show that construction costs rose sharply during the winter months. Huge sums were spent on purchasing firewood for heating, wax for candles to extend the working day, and additional pay for workers in harsh conditions. Despite the costs, Edward I demanded that work continue at any cost in order to consolidate his hold on the conquered lands as quickly as possible. Preserved royal accounts testify to the colossal sums spent on winter construction. Carnarvon Castle alone cost as much to maintain during the winter months as a small town. The cost of firewood accounted for up to 30% of the total construction budget, which was several times higher than the usual proportion for summer construction. It was particularly expensive to deliver fuel to remote areas of Wales, where local resources were quickly depleted. The cost of lighting the workplaces reached astronomical proportions, as work was carried out almost around the clock using thousands of candles, torches, and oil lamps. For Harlech Castle alone, several tons of wax and hundreds of barrels of oil were purchased monthly to maintain lighting. These materials had to be delivered from England, which further increased their costs due to complex logistics. Workers' wages during the winter period included not only higher rates, but also additional compensation for health risks and special bonuses for working on holidays. Skilled craftsmen received winter allowances of up to 100% of their normal rate, while unskilled workers received at least 50%. In addition to monetary compensation, all project participants were provided with free meals, warm clothing, and medical care. It was on these construction sites that all the winter construction technologies known at the time were refined and applied on a massive scale. Craftsmen used heated mortar, protected the masonry with straw mats, and switched to interior work during periods of severe frost. Thanks to this organization and unlimited funding, these monumental castles were erected in record time, becoming a monument not only to military power, but also to the engineering genius of the era. For the first time in history, advanced methods of heating construction mortars using special furnaces and boilers were systematically applied on Welsh construction sites. Engineers developed mobile braziers that could be moved along the walls under construction to provide local heating for workplaces. These innovations made it possible to continue masonry work even at temperatures well below zero. The system for protecting unfinished structures at these sites achieved unprecedented perfection thanks to the use of specially manufactured protective coatings and insulation. Craftsmen created standardized straw mats of various sizes, allowing any section of the walls to be quickly covered regardless of their configuration. A multi-layer preservation technology was developed using various materials for maximum protection against frost. The organization of interior work during the winter period became a true art form, with dozens of different craftsmen working simultaneously in the confined space of unfinished rooms. Coordinating the actions of carpenters, blacksmiths, stonemasons, and other specialists required detailed planning and strict adherence to work schedules. This system became a model for all subsequent large construction projects in medieval Europe. The success of the Welsh campaign proved that, with sufficient resources and proper organization, any natural obstacles in construction could be overcome. The experience gained on these construction sites was carefully documented and passed on to subsequent generations of master builders. The technologies and methods first used in Wales spread throughout Europe and were used in the construction of castles and cathedrals over the following centuries. Continuing construction work during the winter was a decision that had serious economic consequences. The cost of each stage of the work increased several times compared to the summer season. This was due not only to a drop in labor productivity, but also to a sharp increase in overhead costs. The economic calculations of winter construction required the customer to have a deep understanding of all the associated costs and risks. Experienced managers drew up detailed estimates that took into account not only the direct costs of materials and labor, but also a variety of additional factors. Inaccuracy in budget planning could lead to complete bankruptcy, even for a very wealthy feudal lord. Financial advisors of the time recommended that clients include a reserve of 400% of the summer cost of similar work in their winter construction budget. This increase in cost was explained not only by direct expenses, but also by the need to insure the project against various force majeure circumstances. Many projects were halted in winter precisely because these additional costs were underestimated. The main expense was fuel, which was required in huge quantities to heat workers, heat water and sand for mortar, and light workplaces. Prices for firewood and coal naturally rose in winter, which placed a heavy burden on the construction budget. In addition, workers had to be paid a higher winter rate to compensate for the harsh working conditions and keep them on site. Daily firewood consumption at a large construction site in winter reached several cartloads, which in monetary terms accounted for a significant part of the total project budget. The cost of firewood in winter increased by 2 or 3 times due to the difficulties of transportation on snow-covered roads and increased demand. High-quality wood species, necessary to maintain high temperatures in smithies and workshops, were particularly expensive. Lighting workplaces during the dark hours of the day required a constant supply of oil, wax, and resin for torches and lamps. These materials also became significantly more expensive in winter, as their production was limited by seasonal factors. Lighting a single workplace cost as much as it cost to maintain a worker for a week. Winter wage supplements amounted to 50 or 100% of the normal rate and were paid not only for difficult working conditions, but also for health risks. Skilled craftsmen could demand even greater compensation, knowing that they were indispensable in winter conditions. In addition to monetary allowances, workers received extra food rations, warm clothing, and medical care at the employer's expense. Transportation costs increased significantly in winter due to the need to use sleds instead of carts, hire additional horses, and pay for the services of guides. Delivering even small batches of materials became a complex logistical operation requiring careful planning and significant financial costs. Many shipments had to be delivered by detours, which made the process even more expensive. That is why only the richest and most powerful customers, such as kings or large feudal lords waging war, could afford to continue construction in winter. For most less wealthy lords, the winter break was the only option. Thus, year-round castle construction was not only an engineering feat, but also a financial one, demonstrating the wealth and power of its owner. Royal projects were financed from the state treasury and could count on additional tax revenues to cover the increased costs. Monarchs often used winter construction as a way to demonstrate their power to their subjects and foreign ambassadors. Such projects became a symbol of indestructible power, capable of overcoming even natural obstacles. Feudal lords engaged in active military operations were forced to continue building fortifications regardless of the season, as their safety depended on the speed of construction of defensive structures. In such cases, financial costs took a backseat to strategic necessity. Wartime dictated its own priorities, where every day of delay could cost lives. For less wealthy customers, the winter break was not a disadvantage, but a sensible economic strategy that allowed them to spread the costs over several years. This approach required more careful planning and conservation of unfinished parts, but ultimately led to significant savings. Many castles were built according to this scheme, stretching over decades, but ultimately costing their owners a reasonable amount. Even with all the tricks of the trade, there came a time when the weather made it impossible to continue masonry work. In such cases, the main task was to preserve the already erected sections of the walls to protect them from the destructive effects of frost and moisture. Leaving fresh masonry unprotected meant finding a pile of cracked stones in its place in the spring. Master builders possessed a deep understanding of how different materials behave in extreme weather conditions. They understood that lime mortar requires a certain amount of time to harden completely, and that this process slows down significantly at low temperatures. Incorrect preservation could negate months of hard work and huge financial investments in a construction project. The decision to stop masonry work was not made spontaneously, but based on years of experience and observation of weather phenomena. Experienced craftsmen were able to predict the onset of severe frosts several days in advance, which gave them enough time to prepare protective measures. This moment was considered critically important, since the quality of preservation determined the safety of everything built during the season. The upper part of unfinished walls was carefully covered with a thick layer of straw, reeds, or dry branches. This protective layer prevented snow and rain from falling directly on the fresh, not yet completely hardened mortar. On top of it, they could additionally sprinkle earth or clay to create a sealed roof. The choice of covering material depended on local resources and the climatic characteristics of the region. In steppe areas, straw from cereal crops was preferred, as it had excellent insulating properties and did not rot when wet. In wooded areas, coniferous branches were used, whose resinous substances provided additional protection for the masonry against moisture penetration. The thickness of the protective layer was calculated based on the expected severity of the winter and was usually between 0.5 meter and 1 meter. The material was laid in layers, with each level being compacted to create a dense barrier. Particular attention was paid to sealing joints and corners, where the risk of moisture penetration was highest. A layer of soil 20-30 centimeters thick was often poured over the organic insulation, which served as additional protection from wind and precipitation. This earthen roof was formed with a slight slope for the drainage of rain and meltwater. Drainage grooves were dug around the perimeter of the protective covering to divert moisture away from the base of the walls. Particular attention was paid to protecting the mortar in the masonry joints, as this was the most vulnerable part. Sometimes the walls were additionally covered with mats woven from straw, or even covered with a layer of manure. As the manure decomposed, it released a small amount of heat, which created a microclimate around the wall with a temperature close to zero, saving it from deep freezing and destruction. The lime mortar in the joints was particularly sensitive to freezing, as it contained a significant amount of water. When frozen, the water expanded and could break the still unhardened joint, weakening the entire structure. The craftsmen developed special mortar compositions with the addition of salt, ash, or even egg white, which lowered the freezing point of the mixture. Straw mats were made in advance during the warm season and consisted of tightly woven fabrics 10-15 centimeters thick. These mats were attached to the walls with wooden stakes or ropes and created an additional air gap between the masonry and the outer protective layer. The air gap served as an excellent heat insulator and prevented sudden temperature changes. The use of manure as insulation was a common practice based on an understanding of the processes of natural decomposition of organic matter. Fresh horse or cow manure mixed with straw created a biologically active mass that released heat during fermentation for several months. This method allowed the temperature to remain above freezing even in severe frosts, ensuring that the mortar gradually hardened. Specially appointed caretakers monitored the condition of the preserved walls throughout the winter. They regularly checked the integrity of the protective coatings, removed excess snow, and repaired damage caused by wind or wild animals. When problematic areas were discovered, repairs were carried out immediately to prevent serious damage to the structure. Despite all the difficulties, winter construction continued, albeit at a slower pace, bringing the castle closer to completion. Every cubic meter of stone laid, every beam made, and every nail forged was a small victory over the elements. The winter season was transformed from a time of inactivity into a time for completing those tasks for which there was often not enough time or manpower in the summer. By the time spring arrived, the construction site was in a much better state of readiness than if it had been completely frozen for several months. Wooden structures for roofs were ready, the necessary materials were stockpiled, and sometimes even entire sections of walls were erected. This allowed active work to resume immediately with the first warm days, saving precious time. Thus, the medieval builders' struggle with winter was not a desperate improvisation, but a well-thought-out strategy. It was based on a deep understanding of the properties of materials, competent planning, and the ability to adapt the work process to changing conditions. It was this flexibility and ingenuity that allowed them to build architectural masterpieces that continue to amaze us today. We can see that building a castle in the Middle Ages was a complex process, and the winter months became a real test of the skill and organizational abilities of its creators. Instead of giving up in the face of the cold, they found ingenious engineering solutions that allowed them to continue their work. It was a quiet but persistent battle between man and nature, in which technology, albeit primitive, prevailed. The experience of medieval architects proves that human ingenuity can overcome the most severe obstacles. The methods they used to combat the cold demonstrate a deep practical knowledge of physics and chemistry, even if it was not formalized into scientific theories. Their legacy is not only majestic stone walls, but also an example of unyielding will in achieving a goal. What other secrets of medieval technology would you like to uncover? Perhaps you are interested in the construction of cathedrals, the creation of siege engines, or the secrets of shipbuilding of that era? Suggest your topics for future videos in the comments, and don't forget to subscribe to the channel so you don't miss out on new exciting stories.